Eh ben, bonsoir à tous, bienvenue donc sur ce meet-up DDD CQRS Event Sourcing organisé par le MUG Lyon et nos amis crafters de Lyon également. Donc, merci à tout le monde pour la logistique. Alors cet événement aurait dû avoir lieu physiquement. Bon, comme vous le savez, c'est malheureusement de plus en plus compliqué. Alors on a décidé de jouer la sécurité, mais sachez qu'on n'est pas du genre à renoncer et donc on est déjà très heureux d'avoir Allard ce soir qui accepte de venir parler avec nous donc de ces sujets qu'on aime bien, donc DDD, CQRS et Event Sourcing. Et on espère bien le faire revenir en mars, cette fois-ci pour proposer une formation dans la foulée, donc en l'occurrence le 23 et 24 mars, si je ne dis pas de bêtises. Donc voilà, on va essayer de reprogrammer ça pour pouvoir reprofiter de tout ça physiquement, tous ensemble. En tout cas, ce soir, du coup, on va déjà pouvoir en discuter en ligne et c'est déjà pas mal. Donc merci à tout le monde et notamment donc à Axon pour tous les efforts que vous avez fait pour que ça puisse quand même avoir lieu. Merci à Allard donc d'être là avec nous ce soir pour faire cette présentation. Alors, Allard va potentiellement faire sa présentation en anglais. Mais il ne faut pas hésiter à poser des questions en français ou à intervenir en français. Allard parle très bien français, mais il est juste un petit peu plus à l'aise en anglais pour sa présentation. Donc n'hésitez pas sur le chat, on va surveiller tout ça. Sachant qu'à la fin, donc la présentation devrait durer environ 1 heure. Donc vers 20 h, on prévoira de toute façon une session de questions-réponses pour être sûr qu'aucune question du chat ne soit abandonnée. Donc merci encore à Axon pour avoir fait l'effort pour la soirée. Merci aux crafters notamment pour la logistique. Merci à Allard pour la présentation. Et du coup, je te laisse la parole.
D'accord. Merci Emilien. Alors bonsoir tout le monde. C'est dommage que c'est pas à Lyon, mais c'est chez moi et pour vous probablement chez vous. Je vais essayer de partager mon écran, voir si ça marche. Ça c'est toujours le premier test. Alors maintenant je vais changer en anglais. Excusez-moi. So I'm going to switch to English because this story for me is so much easier to tell in English, and when I didn't have the opportunity to absorb the French air, French is always a bit more. It takes a bit more energy for me to speak. So I'll be talking about DDD, CQRS, and event sourcing, but mostly in the context of event-driven microservices, a term that has been hyped or is being hyped quite a bit. And I think for the wrong reasons, or at least the hype is not about the actual value, but about some I guess fancy technologies. And in this talk, I want to go back to the basics and really find out what the actual value is and what does it help us to do and how can it do that. So what are the important ingredients? So I really want to take this beyond the fairy tale, and I do promise there are rainbows and unicorns in this presentation. So, like any fairy tale, we start with once upon a time. Il y avait une fois. There was a universal BBC architecture. Now, fortunately, this has nothing to do with the British Broadcast Company in the UK, but this is the box cylinder architecture. And this is an architectural style that I would say is still, to my despair, dominant these days. And there's a few variations of it, but the whole idea is that we have a cylinder that holds our data. We don't want users to access that data directly, so we put a box in front of that. And the box contains our validation logic, right? Our business logic to make sure that not every random data gets inserted into our box. But we also need to present that information to our end users. And we don't want to put that in the same box as the business rules. So we put a box in front of that, and that is where the UI logic goes, right? And then we have rules that you cannot skip a box, or you can only go boxes to the right, but the box to the right cannot go to the box on the left. Anyway, you probably recognize the layered architecture. And it's a universal. It was used to solve all problems, right? This was the default architectural style, and I'm saying was, but it probably still is the default architectural style. If we start building our applications, we build controllers, which are in the left box. We build services, which are in the middle box, and then we have some form of domain representation, which is more of an object relational model, which we then store in the cylinder. And what this gives us is what's called in domain-driven design, what's called the big ball of mud. And the big ball of mud is an architectural pattern where basically all of our, the obvious structure has been lost. There's no obvious structure anymore. It's still there, right? It's still kept together and it still works. It still does what it needs to do, but it becomes very hard to maintain it. And in this particular example of a big ball of mud, I'm not sure if you even want to touch it and grab it. And as you can see, there's still the architect's probably protecting its big ball of mud, not realizing what kind of thing it has built. But the thing about the big ball of mud is that to change it, you can only really add more mud to it. You can only really work on the outside of it. And this might sound very familiar if you've been working on legacy software. Ultimately, everything degrades to a big ball of mud. It's really difficult to maintain the level of structure in old applications. Then in 2014, since this is about fairy tales, the mighty magician microservices came around the corner, and it would solve all problems, right? Because now we had the way to finally get to the modularity that we've always wanted to get to, right? Microservices, the ideal two-pizza team. We've heard all the beautiful stories, and they're mostly that, just beautiful stories. Very little realism as far as I could tell. But microservices would solve all those problems. And then what emerged was the universal microservices architecture. And what they would have is a lot of small microservices that would have certain responsibilities within our architecture. And these services would then invoke each other to get the stuff done that I knew needed to get done. And recently, from a otherwise quite respected company, I read this paper, and they were defending the idea of separating these services into several categories. You would have entity services on the right. They would be responsible for the persistence of data. You would have the business rule or business services in the middle. And then you would have the backend for front-end kind of services on the left of this diagram. And that's box cylinder all over. So now we have mini box cylinders in each microservice, because they have an HTTP controller layer. There's some logic, and then they do invocations to the right. So there's the layered architectural style within each service. But then on a bigger scheme, we have another meta layer of box cylinder. And this is really interesting. So we've taken the practices that give us a big ball of mud, and then we've increased the number of deployment units. And this is very simple math. What do you get? Well, just a big pile of mud. And it's the wrong thing at that point. It's the wrong thing to do when we try to avoid the big ball of mud. What we need to do, and I have to admit, it's fairly easy to do that on a white sheet of paper, but we need to increase the modularity instead. And increasing modularity on paper is very easy. You just draw little boxes and lines between them, but not between all the boxes, but just between some of them, and you use fancy colors. Fortunately, we'll also see how we can actually do that in practice. But once we get to that modularity, once we've increased the modularity of our system, and it can still be a monolithic system, then we can increase the number of deployment units. And that's where we get to actual microservices, and microservices that make sense. with boundaries that make sense, that are properly reusable, or at least have a very good reason to be separated from the rest. But there, just like any fairy tale, there's something evil lurking around the corner. And in this case, there's evil anti-modularity forces around. And these anti-modularity forces, they come in different shapes and forms. In some companies, they wear a suit and tie and tell you that the deadline has been pulled forward, or that we're changing direction and we're changing the specifications of what we need to build, et cetera, et cetera. But sometimes, and more often, they come from ourselves, either because we make decisions that we regret later on, not very uncommon, or we just make assumptions towards the future that that hold untrue later on, which means we build up technical debt. Now, technical debt in itself is not a big problem, but as you increase the number of deployment units, paying back that technical debt is more difficult. If you imagine doing a rename of a method in a monolith, you can just use your IDE and do a rename, and then all usages of that method will be renamed. But if you have a distributed system and you're renaming a property in a call, you can't just do that. You have to be backwards compatible. You have to think about forwards compatibility as well. So there's a lot of things to take into account as soon as you have increased the number of deployment units. And actually, when you think of that, why are microservices so popular? Why do we start with microservices on day one? And to be honest, I don't have an answer anymore to that. So that was a little bit problematic, right? But we're not there yet, right? The fairy tale doesn't end, it gets better. Now we have events to the rescue. We have the opportunity to use events for all of the communication, right? We can use event-based microservices, and events are really cool. And basically the idea of events is very simple. We can take two services that need to communicate with each other. And of course, we could have service A just invoke an endpoint on service B whenever service B needs to do something based on something that service A has done. But if we then deploy services C and D, we also need to change service A to do the invocation to service C and D, right? So we need to change quite a lot of components every time we want to change the behavior of the system. And this is where events come in. So instead of poking these services directly, what we can do is we can publish an event to a specific location. And these services would just watch that location and just read their own copy of that event. And now all problems are gone. So what we get is the universal event-driven microservices architecture within quotes. And basically, we just have the same services as we had before, because what was wrong with that? But now instead of having them communicate directly to each other, we'll have this massive message bus in the middle, and at least we can tick off some of the fancy technology boxes so that our resume looks really good. And now all communication is through that event bus. So we can just add components, and they can randomly read messages and just post them as they please, right? And this is something I've seen, and it scares me quite a bit. If you're into domain-driven design, then you know the term bounded context, and you want to be able to control where messages go. But this is a concept that certain environments have tried, and they find out that maybe events aren't as easy as they thought they were. So a little recap of our little fairy tale here is, so we used to do box cylinder or layered architecture, but that, especially given the complex nature of systems that we need to build nowadays, we get a big ball of mud. So then we tried to decompose our application, and now we get a big pile of mud. And so now we do event-driven, so we just change the communication, and for some reason we expect that everything is fine, right? And well, if you put it on a slide like that, it looks very naive. I do have another version of the presentation that shows what you actually get, but It's just a big pile of, let's call it mud, with events sticking out of it. So it seems like we're expecting that an event is some magical fairy dust, or pixie dust, if you will, produced by unicorns, used by software developers to make their products scale, perform, and do exactly what the product owner intended. Events like, well, the word event is pretty easy, but in reality, things are always different. And to others, an event is anything that is asynchronous communication. Right? If some form of communication is asynchronous, we immediately talk about events. And the picture we paint to ourselves is this picture of this really beautiful environment. Like, this is where you'll be. Right? Everything will be fine. Nothing to worry about. There's sunshine. There's forest. Or there's a cascade, a waterfall. Sometimes French words come easier than the English ones. And this is where we want to be, right? This is where we want to go, because this is really beautiful. Unfortunately, reality is different. In reality, there's always these tiny little things that annoy us, the little things that we didn't see from a distance that you only know when you get there, right? And this is the reality that we need to deal with. And there's a lot of those little things. There's a lot of these little mosquitoes in any event-driven system. So next time you have an idea for a mechanism of something that should deliver value or do what you think does something for the business, instead of trying to go straight into microservices and on day zero just paint all these boxes with responsibilities and arrows between them, try not to go there straight away, because that is a dangerous route. It is very likely that you get some of the boundaries just a little bit wrong, that you end up with this increased difficulty to pay back that technical debt as you go on. And you just build a distributed monolith or a distributed big ball of mud. Right? That is not an ideal situation for anyone. And I'm not even talking about the extreme complexity of any platform that we want to build microservices on. Right? Deploying monoliths is so much easier and more convenient. So why don't we focus on delivering some business value first, and then getting to the technical aspects later on? And that's very nice in theory, but how does that work in practice? So what we would need to do is build a monolith, but build it in a structured way. And if we do that, we can then, as time evolves and as the non-functionals of our application dictate so, we can then extract certain components and start deploying them separately. And as time evolves even further, we can extract more and scale more of these components as we see the needs arise. But those needs will always be non-functional, because in terms of functionality, there's no difference between the monolith and the microservices. So that's all nice, but how do we do that? How do we build this modular kind of monolith, sometimes called a modulith? And one ingredient that I've found very useful is domain-driven design. Now, if you're not familiar with domain-driven design, I do recommend that you spend some time finding out about it. But be careful, because there's a lot of very abstract talk about domain-driven design. There's some very there's quite a lot of enthusiasts, but some of them are very pragmatic and some of them are more theoretical. So if you're more a pragmatic person, be careful not to dive into the parts of the community where all the theoretical discussions happen, because you'll be very quickly distracted. I'm quite a practical person myself. If something doesn't run in production, I'm not too interested. So the idea of domain-driven design is that you take a domain, and the domain is just the world around you. In this particular case, it's literally the world in this particular example, but the world around you. So if you're in finance, it's your finance world, right? It's where all the rules, the habits, the customs, the requirements, they all come from that domain, right? There's a certain way people talk, there's certain expectations, et cetera, et cetera. And because that domain is so complex, we need to choose certain aspects that we care about to solve a particular problem, right? What kind of problem is my system trying to solve? And in the example of the world, one problem we had was travel. So we built these models that allow us to travel. And this is a particular example of such a model. And it solves a very specific problem. Unfortunately, this is a very similar model to this one is used in schools to teach children what the world looks like. So children think that Greenland is a massive country and that Mexico is really small and that Brazil is also not that big, right? So we have to mind the Amazon. Well, we still do mind, but there's a lot more to it than a surface to it than we would think from this map. But it's not about landmass, right? This map is about sea travel, right? It's the Mercator projection, and you can put 2 dots on any coastal place, and you can draw a line between them, and the angle of the line tells you which direction to sail, and the squares in the ocean tell you are an indication of the distance. And that is really useful, but typically not a problem that we face day to day, at least not us, I guess. And here's another model. Now, this is an ancient map of China, and the area, so there's this white area, this white circle around it. That is the world. And then the part within that, taking about 95% of the surface, is China. Now, is this a wrong model? Is this a bad map? No, it's not. It served a different purpose. Right. So all models are wrong, but some are useful. Definitely is a true thing to say about these models too. And it's pretty obvious that what happens abroad is not the primary concern of whoever is using this map. Right. And this is probably also not a map very useful for ocean navigation, but probably they didn't care about that at that particular time. So domain-driven design gives us a lot of tactical patterns, a lot of modeling practices. How do we go about to create these models? And then it gives us building blocks to actually implement these models in software. And some of these building blocks, entity, value, object, repository, aggregate, event, etc., they are very useful and very powerful. They're basically the tools that we can use to build our systems. But domain-driven design also comes with a number of strategic patterns, and these are more abstract, I would say, but also very valuable. Things like bounded context, and that's a term that's being used for a little bit of too many things, I think. Some people say, I create a bounded context. No, you don't create a bounded context. You define the boundary of a context. So certain words have certain meaning, but maybe only in a particular context. For example, if you take air travel, then you have a flight, right? And that flight leaves at a certain time, and then it arrives at a different destination at some other time. So your departure time is the start of your journey. And the arrival time is where that plane lands on the other side of wherever it is that you're going. But if you're ground crew, you also have an arrival time and a departure time, but they're in the same spot. And the arrival time is before the departure time. So while you talk about the arrival time of a certain plane, it means different things to different people. For ground crew, your destination is not interesting to them, right? So you have to be very careful about the context in which you use certain words or make certain decisions to model something. And then there's context mapping. So ultimately, everything needs to talk to each other somehow. So we need to make sure that nothing is lost in translation when we're talking to other systems that might have a slightly different language. And you want to be very conscious about that. And domain-driven design is really nice in adding structure to a model. So instead of just having grayish components that are all communicating randomly with each other, we can very clearly identify, okay, these are aggregates, these are different contexts, these are contexts that are mapped using certain principles, and this is the way that we separate the communication between the two so that both can evolve relatively separate from the other components. And of course, in software, it doesn't look like that exactly. So that's all nice. That gives us structure to potentially get to that first spot. But how do we then make it so that later on we can just extract these components? How does that magic work? And there, to answer that question, I want to go to the Reactive Manifesto. So I'm not talking about reactive UIs. This is also a term that means different things in different contexts. But I'm in the context of architecture, where we talk about reactive systems. And there's a document which is definitely a recommended read, which is the Reactive Principles. You can find it at principles.reactive.foundation. I've had the pleasure myself to contribute a little bit to it. But the idea of these reactive systems is that the message-driven aspect of it is at the foundation of being able to build elastic and resilient systems which are needed to build the responsive, extensible, and maintainable systems that we require today, given the very complex circumstances that sometimes we need to build these systems under. Right? So I want to focus on that message-driven. And when we talk about message-driven, the fairy tales start buzzing around us, and we think about events immediately. There's the events again. And this is, for some people, almost a one-to-one translation of message-driven. That's when we use events, right? We use events to communicate. But if you look at why components communicate, there's actually 3 reasons why they do so. And one of those reasons is indeed the event, but there's other messages as well. There's commands and queries. And the idea is that when a component communicates to another component, it is either to tell that component to do something. So component A talks to component B and says, B, you now need to do that because I have a user and it wants it's ordered a shipment and I need you to ship it. Right? It sends a command. And there's an expectation of a side effect. There's an expectation that the state of the system changes as a result of the execution of that command. The other one is the component wants to notify another component something happened, right? It can dislike it, but it cannot reject it. It has happened already, and it's just a notification of that particular event, right? And that's what we use the event for. But then there's also the query, which is a need, an expression of a need for information. There's a component that needs to make a decision based on information that it doesn't have itself. So it can ask another component to provide that information so that it can make a decision or present it to the end user, perhaps. But the intents of each message are clearly different. And by modeling these explicitly with these in these types, we express the intent explicitly, and we get some very nice advantages. But the most important is to realize that an event and a message are not the same thing. Right? Events are examples of messages, but not every message is an event. Now, these different messages also follow different routing patterns, and the event is quite popular, and the event uses a pub/sub pattern. Right? We're talking about an occurrence of something in the past, so it's fine to use pub/sub for that. Right? Any component that is interested to know that something happened can subscribe to that particular type of event, and then it gets notified. But then there's little mosquitoes, and the little mosquitoes are, but how about competing consumers? Sometimes if we have multiple consumers that do the same thing based on events because we've scaled it up, for example, then each of them needs to get a message and then compete with the others for that message. So a message would have to go to one of the 3 and not all 3. But in some other cases, we want parallel consumers because we have 2 consumers that do different things one sends emails and the other one updates information in a database, in that case, they both need a copy of the event. We also want to make sure that we get consumer balancing so that when we have three potential destinations, that not one is extremely busy and the other two are doing almost nothing. Right? And something really difficult with events is sequential processing guarantees. Now, we don't always need full sequential processing, but very often we expect a certain event to be handled after another event. If something is created and then updated, or even sometimes the updates, they have to be processed in a particular order. How can we guarantee that? And fortunately, there are solutions to, there's answers to all those questions. But if you take a naive approach and just go full on event driven, these little mosquitoes might bite you. Now, command routing is slightly different. When you send a message to trigger a side effect in a system, you want that side effect to be triggered by a single component. Otherwise, the side effect might be triggered twice, which is generally not what we want. So a command is typically routed to a single destination. And since it's about the side effect, the only message back is more of an acknowledgement that the message has been processed, has been accepted by the system, and is processed. In some environments, it means that it has been processed, so be careful what the exact semantics of the acknowledgement are. And something that we can actually use here as an optimization is consistent hashing. So if you send multiple commands to the same entity or same aggregates in DDD terms, then you can use consistent hashing to send those commands to the same destination. So that at that destination, you can do certain local optimizations, such as caching or pessimistic locking, to make sure that these commands get executed sequentially and that you still have the consistency guarantees that you would want from an aggregate. The query is actually a very interesting one because it doesn't follow a single pattern. We have identified 3 different patterns for queries, and the most common one is the point-to-point. And this is actually the one that is easy to implement using HTTP. The others, as you'll see, are slightly more complex. But a point-to-point query is typically a query that has a single authoritative answer. You just want to get the state of something, and you just want the response, right? There's one true answer, and I don't care which component gives it to me, I just need to have it. So they get routed to a single destination, and that particular destination gives an answer. And it doesn't really matter which one you pick. So we can use round robin, or in some cases, that's one we use in Axon, is performance-based routing. We keep metrics on which component is fastest at answering, and they get slightly more of the pie than the other components. But not all questions have a single authoritative answer. Sometimes these components come back with an opinion. For example, what is the price of a particular product? For example, a hotel room. What is the price of a hotel room? Well, it depends. There's a lot of potential answers. And do you have a membership with the hotel chain or not? Or are you booking well in advance? Through that site? Do you have a particular agreement for corporate pricing? It can get very complex. So there's no single answer to the question, what does it cost? So in that case, you can use a scatter-gather query. And unlike the point-to-point, the scatter-gather is scattered to any component that could potentially provide an answer. And the fun thing is, when a component goes down, it still works. You just get less answers. You get just less to pick from. But we can also add more components. We can add temporary components, and we can remove them later on. And we can change the behavior of the system by just adding components to the system and not changing anything that already existed in that system. Now, something to take care of is typically the response deadlines, because as a sender, you do not have any guarantee of how many responses you're going to get. So you have to set a deadline that you find acceptable. And then the last one is an interesting one, is the subscription query. The subscription query is basically a question that starts with keep me up to date on. So you ask a question, you get an initial answer, and as you get the initial answer, you get updates when that answer changes. So instead of just taking the answer and leaving with it, you keep that connection open, and every time there's an update to the answer, you receive that update. And this is a very powerful principle or a component or mechanism, if you will, to build real-time user interfaces. And real-time user interfaces are, I wouldn't say a necessity, but they're a very useful concept in event-driven systems, because everything in an event-driven or in a message-driven system, I have to say, everything flows, all the messages flow. But typically when we go to the front end, things stop flowing. We start doing polling. We start sending a command and then doing a query and pretending that is the answer, and we return that. If we include the front end in that flow, we can now use server-sent events, for example, to update a user interface in real time, so that we don't have to query the data. We just get it as things are updated, either by ourselves or maybe by other users. And the subscription query is a mechanism to deal with that. Now, why am I talking about all these messaging patterns, and why is that relevant? Because when we use explicit messaging and we have these, we are very clear about the intent of every message we send, and we follow these routing patterns, then we can get something that's called location transparency. And location transparency is the ingredient that allows us to have components communicate with each other without them knowing whether they're part of the same deployable unit, or are they deployed separately, or are they even scaled, right? So if there's multiple destinations, or if a component is deployed several times, that doesn't matter. The sender just knows I need to pick a single destination, or I need to do consistent hashing to find a single destination, etc. And location transparency, well, it starts with good API design, which is more about messages, sending messages, and not expecting a response immediately, but rather embrace the fact that you don't know when things are going to complete, right? I'm going to send a message, I will expect a reply, but I don't know when. Right? So if you're a Java developer, use completable futures. I'm not sure what the .NET variant are, but there's this concept of promise in JavaScript. So whatever the mechanism is, just don't return the value straight away. Don't force consumers to wait for the answer, but let them go on. And when the answer arrives, they can then deal with it. But there is something about events, right? While we are talking about these different messages and trying to get from event-driven to message-driven, there is something about events that makes them very powerful. But there was also a lot of misunderstanding, and recently there was an article by Confluent that caused a bit of chaos, I would say, in the community because of certain use of certain terminology. Imagine we have two services, and each service has its own storage for its current state. And as service A makes modifications to that storage, it emits events. It emits a message that something has happened, which caused it to change its local storage, and it can put that on a stream, right? It can use a specific storage mechanism for events, and then service B can consume those messages. And it doesn't really matter if service B does that in real time, or does it go back in time and replays every now and then, does a full replay. That doesn't really matter, right? Because these messages are stored, we can play those messages whenever we like. This concept is called event streaming. Unfortunately, a lot of people use the term event sourcing for that. They say, well, service B is event sourced. That is not true. Service B is unfortunately not event sourced. it's using event streaming to project an event stream into probably its own database. And when we use event streaming, that's actually quite something really interesting happens. So if we look at what actually happens and the information that the service stores, we see a certain pattern. So we see that an order was created and 2 items were added, right? We have 2 chairs that were added to the order. And every time something happens, we change our local storage, right? We change the representation of what we think the current state of that order is. Now we remove an item, and now on the right, you see there's only 1 chair in the order, right? So the other chair just vanished. And then we have the order was confirmed, we change the status. So the previous status is gone. And as we go on and on and on, and the order is shipped and it's canceled by the user, but because it was shipped before it was canceled, we have to wait for the return shipments. Now, if you look at the right-hand side, you see the story is somebody bought a chair and sent it back. But if you look at the story on the left, it says, no, somebody had the intention to buy 2 chairs, changed their mind, then confirmed, and then changed their mind again. Now, that's a completely different story. And I'm not a retail expert, but if this is a pattern that you have on your website, you might have, maybe there's not enough information about the particular chair to have people make their decisions on, right? So they're second guessing. I need 2 chairs, but I'm not too sure about this one. I'll just buy 1 and see if I like it. So we end up with 2 separate truths, right? The truth on the left, which is what actually happened, but the truth on the right is the less correct truth, but that is the one we act on. And that's quite strange if you think about it. We're acting on a less than ideal truth in our system. And that system can even emit events, but we have no way to really tell which truth is the truth. And the value is on the left-hand side and not so much on the right-hand side. So why do we store the information on the right-hand side? Why don't we decide to just remove that and only store what happened? Now, if we go back to our event streaming diagram, what we would have to do to be able to get rid of that storage is in service A, we would remove the database and have service A make its decisions exclusively on the events that it emitted in the past. And when you make decisions based on the events that you emitted in the past, and then as a result, you append more events to describe now what happened as a result of that, that is when you do event sourcing. So event sourcing is not about 2 services, it's always about 1 service. So event sourcing is something you do to yourself. I store my events so my future self can use those events to make decisions going forward. And this may sound like a technical, overcomplicated solution. In my previous talk, I was there was an attendee who had 10 years of experience with event sourcing, and he said, I cannot unsee it anymore. If you get into event sourcing, things are so much simpler to reason about and to implement that it's really hard to go back to state stored decision making. He said it's not so much, event sourcing is not complex, it's just unfamiliar. So we have to familiarize ourselves with it, and then we can see the value. Not saying that you should use it everywhere, but in a lot of places, we just skip it as a solution because we're not used to building systems this way. So event sourcing is about capturing the truth, the whole truth, and nothing but the truth. In other words, if something happened, it happened because it's in our event log. And when it happened, we always use that to base our new decisions on. So we have a guarantee that every decision we have in that event log was created based on the knowledge of any decision prior to that, or at least the relevant decisions prior to that. Because we still want a little bit of concurrency in our system. But if something did not happen, it can only not have happened if there is no entry for it in the event store. So we don't have the risk anymore that we made a decision, but for some reason the publication of the event went wrong, but the decision is still, or the effects of the decision are still represented in our local database. So why would we want to use event sourcing? Well, there's a couple of business reasons, right? Let's say a simple value proposition, if you will. So first of all, it makes our decisions much more reliable. We know exactly what we have decided and when, but also why. And that is a very useful ingredient for auditing, right? There's some tweets from the principal architect at Barclay Card US, and he said, finally, because of Axon, the audit is a breeze, because they have stored everything. If the auditor wants certain information or wants an explanation why something happened, well, everything is in the event store, so we can just project that into whatever model the auditors would like to have to be able to answer their questions. But not everybody is in an audited environment, but transparency, especially around data these days, is very important. If you make a decision, very often you need to be able to explain why you've made that decision. And doing that after the fact in systems that are not designed this way is quite difficult. And then there's a new movement around machine learning, and using all of the valuable data from these events, from specific behavior moments, I would say, in a system, you can derive value from that data, either using data mining, analytics, whatever technique that you would like to use. But there's also a bunch of technical reasons. So even if the business reasons aren't enough, there's a couple of technical reasons. And the biggest downside is the lack of familiarity we have with event sourcing in software, because in life, everything is event sourced. How often do you replay what happened to decide what decision to make now? So in our brains work in an event sourced fashion, but for some reason we've unlearned that when building software systems. And I like the last one the most, actually, which is to deal with complexity. Certainly especially in more complex environments, it is so much easier to reason about the behavior of a system in terms of what happened in the past than it is in terms of what booleans do I need to flip in a table, or what property do I need to change to change the behavior because there's an if statement that looks at the value of that property. Right? There's always this implicit knowledge when using state-based systems that becomes much more explicit when we used event-based decision-making. But event sourcing is really nice in telling you how you got to a specific point in time. How did you get to a specific state? Right? It gives you the trail of history. But sometimes you just need to know where you are. Imagine you're lost in the woods trying to find that really nice waterfall, and there's somebody you're lost. So you ask this fairy tale figure where you are, and the only thing it tells you is how you've been walking. Now that's probably a very long description, and also not very useful, because you don't need to know how you got there. Sometimes you just need to know where you are. And if you want to know your account balance, you just want a number. You don't want the list of all the transactions that you've gone through, which obviously will tell you what your account balance is, but it's not a very efficient way to go through that data. And this is where CQRS complements event sourcing quite a bit. And the idea of CQRS is that you split your application into two parts. One part is responsible for making decisions on state changes of a system, and the other part is responsible for providing information about the current state of the system. And the nice thing about this in combination with event sourcing is that we can use event sourcing on the command side, where every decision that we make is explicitly based on decisions from the past, and we append events to that stream. log, if you will. And then as we append events to that log, they get projected to the read side of our system, so that when we ask a question, the data for the answer is present. So that projection side is designed to answer your questions efficiently. And typically a question arises, yeah, but what about eventual consistency? What about I make a change and then do a query and I don't see the results of my change in the query response just yet, right? I confirmed an order, but the state is still pending. Right? And because of that fear, what we very often do is we try to avoid it. So this eventual consistency is a scary thing, right? We feel it's new. It's not, but it's how it feels. And the more we do to try to avoid eventual consistency, the more we get the only thing that's worse: eventual inconsistency. And I've seen so many systems that said, yeah, we need everything fully consistent, but every now and then this side does not really match that side anymore, and we use a consolidation engine. I mean, if you're working banking, in banks, there's a lot of systems that make decisions, but they tend to diverge a little bit. And to avoid that, they have consolidation systems that consolidate what's going on one side and the other side, compare it, and make sure it's equal. But they do that knowing that it's not always equal. And when it's not, you now have two truths. Which one is the truth? Or is the truth somewhere in the middle and they both need to be modified? And that becomes really difficult. So try to embrace eventual consistency instead of trying to avoid it. That is very, very helpful. Basically, you have to be event-driven. And how do you do that? Well, it's not that difficult, right? Just use events. Well, there's a lot of these little mosquitoes, and I have talked about quite a few. This is not to scare you away from anything that is event-driven, but this is a shout out to use proper tooling. We tend to pick whatever technology is fancy or does something with events, but not realizing whether it really solves the specific problems that we have when going for this event-driven approach. Now, obviously, one of those tools is what we build at AxonIQ. There's two components. There's a framework and there's a server, and they serve different purposes in these in this style, in this architectural style of things. Now, the framework is a free open source Apache licensed framework for the JVM. If you're on .NET or in any other language, there's probably a framework that can help you there as well. But Axon framework is built on the foundation of domain-driven design, CQRS, and event sourcing, which you can pick and choose. You're not forced to use them. But when you use the framework, you'll see terminology that is very familiar if you are used to domain-driven design. An Axon server is basically a messaging component that is aware of event sourcing, and it acts as an event store, but it also can take care of the routing of all of these messages for you. I'm looking at the time, whether I should show a little demo or not. Maybe we keep it to the end to see if we have enough time. So I can show you how this location transparency actually gives a pretty boring demo where we have a monolith and we can extract components from that monolith and run it, and the behavior doesn't change at all. It's all very transparent. And that's because of these routing patterns that are implemented in Axon Server based on what we saw earlier. Now, Axon Server is also, there's a free version of it, and then there's enterprise versions if you want to take it to the large scale. And the idea of that messaging, and what I think is missing, has been missing for a long time in the portfolio of messaging systems that we had around, is you can place these messaging systems on a scale of how smart they are, or about how knowledgeable they are about the message they transport. So it's not smart is good, dumb is bad, or the other way around. It's just different, right? It's a different choice of designing a messaging system. Now, on the smart side, we have the enterprise service bus. It understands the messages it transports. It can do transformations of payloads. It can invoke services using different protocols based on messages. So it can transform messages, translate the protocols. It can do a lot of things, right? It can make decisions. It can park messages and then forward them later on. Really powerful. But the disadvantage is that you start programming a lot of logic into the message bus. And many find that that is not the place to put the logic. Just like we stopped doing stored procedures in our databases, mostly because we find that the applications should have the behavior. So we went all the way to the dumb side with message brokers, right? The AMQP-based message brokers, for example, where you just send a message. The broker has no understanding of the message whatsoever, and it just puts the message in a queue for any destination to read. But if you then have competing consumers, you have to have them read from the same queue, but give a different queue to consumers that are parallel consumers, etc. So things can get a bit tricky in organizing it the right way so that the messaging is still executed the way that you want it to. And where we feel the right place to be is still on the left side, still on the dumb side when it comes to knowledge about the payload, but slightly smarter than the typical message broker. And the way we call that is stereotype-based routing. So the only thing we want to know is your message a command, an event, or a query? And what is the name that I can use to identify the type of command, query, or event? And based on that, I know where to route it. Because an application will have indicated, I can handle commands with these names. And because it's a command, I know I can use consistent hashing to route it to one of the destinations that has told me that it can handle that particular type of command. And that's why it's zero configuration and application driven, right? There's no explicit configuration needed to change the routing. The applications tell you what they can do, and based on that, the routing automatically adapts. But to be event-driven, or message-driven actually, but it takes a bit more than pick whatever fancy technology, including our own. It takes more than whatever technology you can think of, right? To be truly event-driven takes wax on, wax off. Now, some of you might not be old enough. This is always the slide where I realize that I've come to a certain age where, well, let's say a significant portion of people will not know what this is. This is a scene in a movie called Karate Kid. And the boy on the left is... I can't remember if he's bullied at school but there's a girl involved. So he wants to conquer the heart of the girl, and he wants to learn karate. And so he finds a gentleman in his village who can teach him karate, but the gentleman doesn't want to do that. Ultimately, he convinces the gentleman to give it a try. So Mr. Miyagi is going to teach Daniel how to do karate. So he says, here's sponges, here's wax, there's my car, go wax my car. Now, the thing about the whole scene and how it applies to event-driven microservices, or any software engineering actually, is to learn the cool stuff. Sometimes you have to do the annoying stuff, and not just once, but over and over again. We have to get used to the thing that we don't like, right? And this movement that he did, waxing the car, wax on, wax off, was not only about the discipline to make that movement, and learning karate is a mental thing first of all, but ultimately he uses that movement to in his fight with the evil guy from school. But the wax on, wax off, fortunately, in software engineering is not about waxing cars. It is more about these practices that we need to get used to and apply more and more to get better at it, which are things like event storming, a very useful concept when you want to explore basically what a specific system is about. And that system can be a socio-technical system, so it involves people as well as machines. And in some cases, it doesn't even need to involve any machines. You can use event storming to basically on everything in life. And another one is event modeling, which is a little bit more focused towards building software systems. But it also starts with events. It starts with explaining what happens in a system and how does that feed information that we need to see as a user to then make a decision on which button to press. And what action does that button then trigger? And what decision do we make? What events come out of that decision? And then what information is again triggered by that particular change? And as we go on, we basically design the entire system. And once you have that, implementing it becomes a lot easier. And then there's obviously domain-driven design. If you haven't done so, I can recommend reading that blue book. It is a very old book. It's almost 20 years old now. I think it's 18 years old. But it is more relevant today than it was when it was written, which is, I think, for a software book, something that you don't see very often. So far for the wax on, wax off. I think we are 1 hour into the presentation. If you want some more information, here's a couple of links that you can use to find out more. Feel free to contact me if you have any questions, or better, if you have any questions, maybe we can move to the Q&A. And for those really eager to see the demo, just let me know in the Q&A, and then we'll spend some time on that. Oh yes, and if you want to ask your questions en français, that works for me as well. My spoken French is not as fluent as my English, but I can generally understand it quite well.
Okay, thank you very much, Allard. So I think Anthony has got the question for you. Could you try to?
I find the question as well. I can read them out if you prefer.
I think someone put the question, but Romain say this is mainly infrastructure issues. If you have a single instance, you shouldn't ask yourself such questions. That's the question is this is mainly infrastructure issues? Question mark.
Actually, he was talking, I think, when you were talking about what kind of, if you go back in the slide, the different architecture you could use for eventual consistency and stuff like that. And his point was that I guess it's not directly relevant for CQRS, yes, and even if indeed we often see this kind of problem, it's more an infrastructure issues than
Yeah, so if you have a single instance of an application, you can use your event dispatch mechanism can just use the thread to dispatch it. And that is actually the way that Axon, I would say versions 1 and 2, we are now at version 4, but 1 and 2 works by default. And that bit us, or worse, it bit our users, because there's a saying by Martin Thompson, which is synchronous programming is the crystal meth of software engineering, right? It will make you feel really good for a very short time. But as soon as you start scaling, and if you have a single instance, that's fantastic. But are you going to have a single instance forever? So sometimes it's better to just get used to asynchronous behavior in the first place, and embrace, as I said, embrace eventual consistency, because you will have to at some point. If you if you don't, then you're stuck, right? And then it takes quite a bit of effort to then change that system to then again embrace eventual consistency. And as I said, we try to avoid it because it's scary. I've been doing this now for 12 years. The notion of trying to avoid it and then having to change it later is a lot scarier than embracing it. But it's unfamiliarity. Sometimes things are scary because we don't know how they work. But there's so much information nowadays, and there's so much knowledge of how to deal with it that it is easy to find answers to your question. So I see a question here from Itar31. If I consider the following business use case, we need to execute some messages in a specific order. For example, create, update, 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 update. How could we meet this business requirement using an event-driven architecture, knowing that several instances of the same service could listen to the same topic? Then the risk of messages could be handled in a different order. So I think that's a messaging problem. And maybe that is the infrastructure problem that was referred to later. So create, update, update, update are commands. They're not events. So the first problem is when we use an event-driven mindset and everything is an event, then we have a problem. But if we take the explicit messaging approach and we treat those as commands, then a system transporting commands from origin to destination can know that commands that are sent in a particular order should also be delivered in the same order as much as possible. And because of the consistent hashing, they will be delivered to the same destination. Still, it might be that some component somewhere does something asynchronously, and you can still have commands overtake each other. And this is where you can embrace the asynchronous nature of messaging and say, I want to do the create, and then I want to do the update. So when the create gives an acknowledgement, then send the update, and then send the next update. It introduces a little bit of latency, but typically, it will give you more security as well around ordering guarantees. Right, let me see if there's some other question.
Yes, there is, but I haven't recorded all the questions. So
my 2 cents, event sourcing. So there's a Buijze, if I'm pronouncing that right.
Yeah.
My 2 cents, event sourcing is a storage mechanism to store, retrieve state within a service. Event streaming is a communication mechanism between services, different purposes for different usages. Really well described in event-driven I/O. Event streaming is not event sourcing. Yes, definitely. There's a lot of information nowadays because there's a lot of confusion around event sourcing and event streaming, and they're very often confused. So yes, event sourcing is replacing state storage, and the thing that makes it complicated is when you use event sourcing, you can use the stream that you generate by event sourcing, by producing those events. You can use that for event streaming, which is the same source. Well, I guess you get where we are, right? There's the terminology seems to really nicely fit, but the word source is used in different.
There is a question. How we handle the delay between the store moment and the UI validation?
Are you suggesting that the hard part of software development is actually not programming? Yeah, well, I think asking the question is answering it, right?
That was actually a joke. Yeah, don't worry about this one.
It's
It was an answer to another question. But I know that some people would love to see some code actually to see how Axon could help. I don't know if we have other questions before we switch to see some code.
If you've asked the question on Twitch somewhere, please copy paste your question again, mark it with question, then we can find it a little bit easier.
Yes, there is some question like what
I think that
yeah.
Yeah, sorry. There was one. Copy again. There was one about the storage, the size of the storage and how you handle it, because of course you have a bigger storage for events than for states.
Yeah,
that's a classic one.
Yeah, so if you store a lot of events, obviously you need more storage. So typically the storage itself is not problematic. Yes, it costs a bit more to store more data, but typically the big problem is how do you manage the data, right? Getting it onto a disk is not the hard part. It's not even the expensive part. The expensive part is making the backups, making sure that the data is quickly accessible as well. And this is why we've decided a couple of years ago, almost 5 years ago, to implement a built-for-purpose event store. And as far as I know, there's only 2 implementations of such an event store, which is Axon Server and Event Store by Event Store, the company. And those are designed for event sourcing, and they both have slightly different approaches on how to work with events, but the idea is still the same, that the performance of the system should not degrade as you store more data, which is typically a problem if you use a relational database. So with a relational database, storage becomes an issue, because even though the disk is not that expensive, managing and accessing the data becomes more expensive, slower, taking more CPU, etc. Now, there's actually an interesting comment. Are you using the same events to store data in service A and to communicate business events to service B? Sounds like an anti-pattern. That's actually a very interesting comment or question. It could be an anti-pattern, and it depends. Now, if these 2 services are in the same context, right, they have the same meaning to events, why not, right? Because they speak the same language, they care about the same details, and if the language needs to change, they will both want it changed because they are in the same context. However, you have to be very careful to not randomly spread the information between services. And the term service is slightly misleading. I prefer to use the word components because a component could be deployed separately. It could be deployed in the same service as the others, and that shouldn't matter. But the context is very important. Now, another mistake, and that is definitely an anti-pattern that I've seen a lot, is by trying to avoid this, what happens is that the event sourcing events become technical. And I think that is the biggest anti-pattern. So the business events that you use to communicate to other services, the business events are the one you should store, nothing else. If you take your event stream and you give it to somebody from the business and they don't understand what it means, you've made a mistake. I mean, that's the simplest test I can imagine to get you further. So describe what happened, actually what happened in terms of business, and not what are the effects of what actually happened on my data model. Right? Because if you do that with event sourcing, it will bite you at some time. Unfortunately, I've been there. Yeah, so events for event sourcing should be restricted within a particular context. So they should stay within the boundary of your context. If you want to communicate outside, you probably have events as well, maybe even commands, but they might have, and they typically have a different structure. So I've got a few examples about that in other presentations, but when I talk more about the large-scale implementations of event sourcing, quote unquote. But what you want to do is translate them, because outside services are not interested in the nitty-gritty steps and the nitty-gritty details. I don't care when I place an order. I don't care what little steps are happening. I just want to know, when will it be delivered at my house? Has it been sent out of the warehouse yet? And whatever happens within that warehouse, to me, that's a black box, quite literally sometimes. I don't care about the nitty-gritty details. But when you're in the warehouse, you definitely do care about the nitty-gritty details, because that is how you work. So something has to translate whatever happens on the inside to how we want that represented on the outside. And generally, you will only see things like milestone events, right? They're sometimes called that. Sometimes an event represents something that happened that is slightly more important than the other things that happened before that. Then you speak about the difference between event streaming versus event sourcing. If we use event sourcing plus CQRS, we got event streaming. The first part stores events in event store, and the second part queries the event store and stores the response in other DB. I'm not sure what the question is, because that sounds more or less like yes, correct.
Actually, the answer was already given when they said the difference between event streaming and event sourcing. But indeed, you have a bunch of other questions. How we handle the delay between the store moment and the UI for validation, for example, like ACID and transactional database. How do you handle transaction actually?
Yeah, so that's a very interesting part. And this is where CQRS becomes really powerful. Because even if we have eventual consistency, it does not mean that all our decisions are made on inconsistent data. But what it means is that we explicitly choose our consistency boundaries. Now, we all know that consistency is the enemy of scalability, right? Distributed systems and consistency are generally not very good friends. So we need to choose the consistency boundaries very consciously. And in domain-driven design, there's one explicit ingredient for that called the aggregates. And in the, I think it's in the Reactive Principles document, and I'm not sure who put it there, but there's a really nice quote that the aggregate is an island of consistency in an ever-flowing river of change. So while the whole system is eventually consistent, the aggregates are always in a consistent state. And that means that any decision that we make, which is made by that aggregate, is made on a specific selection of, well, consistent data. So for example, if we take a bank account and we cannot go below zero with our with the amounts we have on the account, we cannot overdraw our account, then the current amount is the data that we want to capture consistently. So when we send two commands to an account, which for example holds 50 euros, and we ask it to reduce to take out 40, we expect one command to succeed and one to fail. And we can only do that if we have full consistency, which on the account we can choose to have by designing that as an aggregate. And that means that the history of the account is being loaded to make decisions. And then when we want to store decisions, we can identify whether it's still the latest state or whether we have concurrently made another decision. And this is exactly how the modeling and the design of an application starts, is you choose your consistency boundaries. But by choosing them small, we can have more concurrency. If you take everything, the whole system as one aggregate, then we can basically only do one transaction at a time, which is challenging, right? So it's something we can we choose explicitly. Now, I have a little demo application. I can show it there as well. I understood that some people wanted to see some code. Now there's a project which is on GitHub, which is github.com/Buijze. Let me share the link. Yeah, I will do presentation mode. github.com/Buijze. Oh, I was trying to put a link in Twitch, but then I need to log in. Let me not do that.
If you put it on Zoom, I will copy it in. Yeah.
Maybe you can double check if the link works, if it didn't make any typos. You can look at GitHub. It's the bike rental extended. And what I've done is, well, being Dutch, sometimes I host French people in my country, and oh, sorry, that was the wrong. We make them ride a bike, right? That's always good fun, especially in Amsterdam. Amsterdam is way too dangerous. I don't even ride my bike there. So we have a bike rental.
Excuse me, Allard, would you mind to go in presentation mode?
Yeah, I will.
We can see really well your. Yeah, awesome. Thank you.
So there's a bike rental, and in the bike rental we can generate a couple of bikes, and then we can rent them. But to be able to rent them, we have to perform a payment. Right? So that is more or less the feature that our system has. So we have two modules: the payment service and a rental service, right? And these services conceptually live in a different context, because payment doesn't know about bikes; it just knows about payments. And rental knows about bikes and does know that those bikes need to be paid for, but doesn't really care how, right? It doesn't care how that works. And we have another module, which is the core API. It's a bit more convenient in demos to just share the classes between services, but in general, you don't want to always do that. So if we go to our application, there's a certain structure. We have our command side. We have a saga, which takes care of the link with the payment system. And because we see rental as the, I always forget whether it's upstream or downstream. I think downstream system. The responsibility for coordinating the payment is within the rental application. Rental knows about payments. Payments shouldn't know about rentals. And then we have the query side of the application, and we have a UI. I'm going to open that. There is actually no real UI. It's just a controller with HTTP endpoints. And there's a bit of application. There's a little bit of configuration here, but this is already advanced. In practice, you don't need any of this to get started. Except maybe for some security. I mean, Log4j was not the first issue discovered in open source libraries recently. Apparently, Extreme also allowed for very nifty code injection by sending certain payloads to endpoints. So we have a UI. There's a couple of endpoints here to generate bikes, to get the bikes, etc. And as you can see here, the generate bikes, let me take a simple one. The get mapping for /bikes just sends a query. It sends the find all query, which is a string called find all. We don't specify any parameters for this particular query because we find all, and all doesn't need to be specified. And what we expect back is multiple instances of a bike status object. And the bike status object, that is our query model. It is an object that represents where the bike is right now. Is it rented? Where was it rented? Is it available for rent, etc.? And that's something on the query side. So on the query side, we read events and we update the bike status. Right? So in this case, when a bike is registered, we add a new entry to our repository. This is Spring Data JPA. If you're familiar with Spring, very convenient. When a bike is requested, we find that and we mark it as requested by the renter. And you see a little bit of update emitter. This is how we send updates to subscription queries. So if there is a subscription query that says, keep me up to date on this bike, then it will automatically emit updates to anyone who's been asking for a particular bike status, or if you have been asking for the all, keep me up to date on all the bikes that are around. And then there's the bike itself. This is an aggregate, so we can mark it. This is already a bit of configuration. You can choose to do it here in an annotation or wherever else you would like to have that. But that's for snapshots, which we didn't even talk about today. But you can see that there's a command handler. So when a bike is registered, this is the constructor, it creates a new bike. We apply an event to notify other systems that or other components that a bike was created. When we handle a request for a bike, then something interesting happens. We check if the bike is available, because the last thing we want is to have two people pay for the same bike and not being able to deliver, right? Then we get angry people in our store. So this is a decision that is made on consistent data, right? There's no eventual consistency here. This is fully consistent. So if it is not available, we throw an exception. If it is available, then we apply the bike requested event, and we use a random identifier to identify this particular attempt to rent the bike. And for now, it's just an attempt because the saga will start when a bike is requested. So there's a start saga, and a saga coordinates the process of the bike rental and the payment, and then the confirmation to make sure that the lock automatically unlocks when our credit card is swiped. So this coordinates with the basically between the rental service and the payment service, and says, okay, I'm going to prepare a payment, which is the process of sending a command, and to prepare a payment for 10. It's a fixed price, hard-coded pricing in this particular example. And when the payment is confirmed, then we approve the request back to the bike. But in between the preparing a payment and the confirmation of the payment, there's a couple of steps in the payment system that we need to do. And that is why in the rental controller, I have a little process which is generate data, which I'm not going to go through in a lot of details, but it executes a rental cycle. And the rental cycle is request a bike. It gives us the payment identifier. Now, normally a UI would then do a redirect to the payment provider using that particular payment reference. So you're on that other page. So I'm executing the payment using that payment reference. And when the bike is unlocked, basically I'm doing my payment and I'm waiting for my bike to, for the lock to automatically open. And then I'm going to return it. Right. So this is only a millisecond rental. Of course, in practice, you want to write it and then return it, but I didn't care about that. So we return the bike at a random location as soon as we detect that it was unlocked, right? Which is a query we do keep me up to date on the bike status. I'm watching the lock. I'm waiting for information from the system. So I can start this. Let me find the services window. There we go. I can start the payment application and the. Now this is always a bit slower when you're sharing screens. So I should have Axon server is running. That one is started. So we should be able, oops, cancel. Should be able to get the bikes. So I'm sending a request for the bikes, which is a query, and it gives me an empty response. So what I need to do is issue a number of bikes, and now I can get them again. And now we see that we have a number of bikes in random cities: Vilnius, London, Paris, Belgrade, Milan, etc. I mean, we're taking biking seriously, right? We're not going from one street to another. We're traveling the world, and so I can get the status of a particular bike as well, which is a different query. And I just get one. It's now available in Toronto. So what I can do is I can generate these rentals. And what we'll see is the one line of message per rental and whether it succeeded or not. And you'll see that some of them did not succeed. Bike already rented. And that is because of the steps that the process takes. It first does a query, give me all available bikes. Then it chooses one. Oh, I want that bike. I'm going to request it. Because this happens concurrently, it is possible that I've seen a bike that I want, and I'm requesting that, but somebody else did so at the same time. And then it fails straight away, like, okay, you can't take that bike, it's being taken by somebody else. Maybe the payment didn't go through for the other one, and then it becomes available again. Maybe it does go through, we don't know. But at that point, it has been requested by somebody, and we want to prevent that bike being rented. So I should be able to go to the user interface of Axon server, and what I can do is query all the events. So I see that there's 140 actually events, and we can see the payload data of every event. So this is a bike returned, and we could take the aggregate identifier, copy that, and we do aggregate identifier. And now we see that this bike has been rented a few times. We can do a real life update and see. Oh, there we go. More events arrive. So as the rental process kicks in, we generate more. All right. So it works, right? Something happens. You can verify the code. You can see that I'm not playing tricks. But now we're going to do something interesting. We're going to pretend like this business is a massive success. And what we can do is we can take these components. I'm going to move. Shortcut again there. I'm going to move these classes into their own modules. I'm going to move that one to the rental payments, which is then the component that will take care of the, oops. Payments. Going to move that to the query components. And why not move that to its own UI components? There we go. So now this application is completely empty, right? There's no point in starting this anymore. But now I have my little microservices. I've got a really small 2-class services that are really focused around doing one thing and one thing only. So my command application can only handle commands. My Saga application is the payment, the rental payment coordination, Of course, it takes a lot longer to start now. You can see it starts at random ports because we don't really need a UI on that one, but the user interface will start on port 8080. All right, so now they've all started. Let me see if I can get some bikes. So I still have the bikes. The query is still answering. I can still get, where was the request? I can still get this request. It's now in Rome. I think it was somewhere else earlier, not sure. And I can still generate a bunch of rentals. And it will still do the same coordination, but now the components are spread and they're in different places. And I should be able to start another. Oops, how do I run? I should be able to run another one of these instances. There we go, command, start another one. There we go. I think I can do that from this UI. No. Too bad. I guess that's a feature request. I can run. Can I do it that way? Yes. So now I'm starting an extra command application, an extra query application, and I can do generate rentals again. Why not? And nothing happens. Now, in the meantime, well, we've generated quite a few extra events. In my overview, I can see that I have one instance of the payment processor. There's two instances of the rental command application. There's the payment application that coordinates the rentals with the payments. There's two instances of the query. And I can see that this application has command handlers only. So these are the names of the commands that I can actually handle. And in this UI, I can see that there's an event processor, which is working to consume all the events and update the projections. And it answers these particular queries. There's two instances of it running. Let me see what else I can show. I can see how the messages have been routed. So the rental command both have, they're balancing the load between them. And the payment processor is only handling the per payment, obviously, because the other services don't have handlers for it. And as I handle commands, you see the numbers changing as it's executing these rentals. So let's make it. So now it's executing 100 of these cycles, 10 at the same time. And you can see that the commands are balanced between the available services, and I can just bring them up and down, and there's no configuration that I need to change to make that happen. Now this one doesn't retrieve anything anymore because it's not running. It was stopped. So as I said, a boring demo because nothing changes, but I can move stuff around and not care too much about how many instances, how do I need to change configuration whatsoever. And also, if you look at the amount of plumbing or infrastructure code, it is quite minimal, right? The bike is about the business logic, right? What does it mean to request a bike? Well, we need to make sure it's available, and then it's requested. When it is requested, and that's where the event sourcing comes in. When the bike is requested, we say, okay, it's been reserved by whoever requested it. The reservation is not yet confirmed and it's not available for rental. And we use those properties to validate new incoming commands. I hope that makes sense. Do we have any questions? Okay.
Well, I posted one in the chat. I was wondering if you ever tried to generate something like an event modeling from your code using Axon, if you know what I mean. You know, trying to, because most of the time you go from event modeling and you design your code, but it's pretty interesting to see how your code is actually following what you are thinking it's doing. And I asked it myself a few times, and basically the only thing I would believe to need to do that is some tags on commands and events and aggregates and everything to identify them and put them in a graph.
Yeah.
So I was wondering if this is something you can see value in, and if you ever try to do something like that.
Yeah, so I've seen a system that actually does that. There's two ways to do it. One is at runtime. So, for example, looking at Axon server, seeing what messages flow by. Hey, this command generates those events. Hey, let's draw them. And that is actually something that we're looking into building. What I do know exists, and I'm not sure if they have updated, but ThoughtWorks has built I think they called it MRI at the time. They build a tool to inspect Axon framework-based code to detect which command handlers you have and which events you would then publish from those command handlers. And they would draw a graph, and then they would see an event handler for a specific event that then updated it. And basically they created a class diagram based on the commands, events, and queries messaging. Which is an interesting idea. It is static, it's based on code. So it only it has the theoretical paths, right? If you do it in production, you can then see okay, a certain command arrived and that generated an event, but the same type of command later generated another event. So you can see those combinations, which is a little bit harder to find out using static analysis. Of course, you can do a theoretical path of what could be possible, but they're not always practical. And that is something that we are looking at building actually to show a sort of functional overview of what communicates with what and with which messages, especially.
Okay, nice. Yeah, that's pretty interesting, because if there is at least one painful thing with event-driven code is to follow the workflow when you want to know exactly what happens when you trigger this command. As you say, you could try to track it at runtime, but when you are writing your code, it's sometimes pretty hard to know exactly where are the event handler and what is triggered by an event and by a command.
Yeah, especially when you're building, let's say, complex systems and you're making a change to an existing system. Sometimes you have to make the change in different parts of a system to make it work, which, well, ideally you don't have to do, but we all know it's not an ideal world. And then it does get a little bit harder. And it's actually not so much because of the message-driven nature, but because of the location transparency, right? You don't know which component of the other side handles it, which is an advantage most of the time. but sometimes it's a disadvantage because you do want to know where it's handled, so you can modify that code as well. So yeah, having something to quickly find that is quite useful.
Thank you. So we have another question in the chat. I don't know if you can see it. In the case, if we have 2 or more instances, if event handling and the command trigger an event, how does it work?
In case we have 2 or more instances, if we have event handling. So
I guess the question is, but you can confirm, Reclad Beraim, si jamais c'est pas ça, tu n'hésites pas à mieux expliquer. Donc je suppose que ce que tu veux savoir, c'est qu'est-ce qui se passe quand un événement, quand on envoie un événement, mais que plusieurs instances d'event handler sont à l'écoute. C'est ça la question en gros?
You mean, so I'll just answer that question.
Yep.
So when you have 2 instances of an event handler, which is exactly what I had, so I still have my query application, right? So my query application is running 2 instances. And if I go to the dashboard in my overview, then you can see there's a processor. If I click on it, you can see that it's the same event handler. So right now, one of my applications is handling those events. And this is because I'm running the standard edition of Axon Server. But now I'm balancing it, right? I'm calling, well, I'm using the UI right now to do it. But what you see now is that there's 16 segments, and segments is how the event stream is conceptually cut into 16 different partitions, if you will. These are virtual partitions. And this application, this instance, the 13.5.16, is doing half of the partitions, and the other one is processing the other half. And this is how we do the balancing. So they both know which of the events in the stream to process and which to leave to the other instances. Now in the enterprise version of Axon Server, this is all automatically balanced. As soon as an application joins, it finds the best way to balance the processing. So if we open, why can't I just have start another one button? There we go. Does that work? Do I then get another one? Yes. Now we get a third one. And just wait for it to show up here. There we go. Now there's a third one active. I can balance again. And it takes a little. There we see now it's balanced more, right? So now the 3 of them are equally, more or less equally, 16 divided by 3, are balancing the load between them. And this is all, the applications coordinate that by claiming these segments. And they will also notice that when another application crashes, so let's say this instance, there's a little unfortunate event that happened to this one, boom, stopped. Now this is the hard stop. And it said, oh, did you see that? It said not all segments claimed. And then the other applications see that and they claim them. And now it's not quite balanced again, because the 4792 noticed that, hey, there are some abandoned segments there. I will take those. Otherwise, some events are not getting handled. So it picks that up automatically, and we can rebalance. And it will drop some so that both have 8 out of 16 events. So it's taken care of. I hope that answers the question.
Ok. We still have a few questions, and after that, we'll try to close the session.
Yeah, unit tests. Right. Good question, Hugo. I think your name is Hugo.
Yeah, so it's mainly integration tests on such infrastructure.
Of course, I didn't create any tests. Bad me. So the beautiful thing is there's a test fixture in Axon. There's a test module, and you can create given when then tests based on well, if you have an event source aggregate, you can say given these events from the past, when I execute this command, I expect these events to be published. Let's see if I can quickly get some. No, okay, yeah. Oops. Does that work? Ah. It works if you put them in the right place and then create the test. Ah, wait, the new aggregates. Okay, I have to put add the dependencies, so it's going to take a little bit too much. But if you there's some examples. If you look at the examples, there's an aggregate test fixture. You can say, given these events, when I execute that command, I expect that event, or I expect an exception, or I expect and it's very powerful because you describe the expected behavior in pure, well, functionality terms, right? Not in functional terms, but in terms of functionality. So given I've requested a bike, when I try to request a bike, it fails because I'm not allowed to do that. Given I wait too long to confirm my payment, I expect that the bike is available again, right? You can express those things in the fixtures. So that's it's actually quite powerful. And in integration tests, they are very similar to any other integration tests. If you want to use Axon Server within the tests, you can use test containers to run the Docker image of Axon Server. We are currently working on a specific test containers module, so you can just say I want to run one and connect my Spring Boot application to it, etc. So I hope that answers it.
Yeah, I think so. So thank you very much. Maybe I have one question to finish. Someone asked when you would, if and we hope so, you come in Lyon, and if you agree to do another talk, what would be the topic? But maybe it's a bit early to discuss that. But
well, let me ask it the other way around. What would you want to talk about, or what would you want me to talk about? I mean,
yeah, that's exactly what I asked him, and he said mostly event sourcing and see more Axon stuff in action. So. So,
you know, I'm always up for crazy ways to do it. And suddenly I was reminded there's well, I'm from The Hague, and there's a place called Scheveningen, and there's a bar in Scheveningen where there's a piano, and somebody plays the piano, and you can write on the notes. You can write what song you want the person to play, and you put that on the piano. And when he finishes a song, he just takes a note and plays that. So that is the easiest for me. No preparation, just tell me, what do you want to talk about? Just put a subject on the table, we'll grab it. But maybe I'll prepare something, but I'm open to any suggestions that you have.
Okay, yeah, we're actually huge fan of open forum as well, so it could be an option. So thank you very much. Donc habituellement, à la fin des présentations des crafters, on propose ce qu'on appelle un ROTI, Return on Time Invest. Est-ce que c'est OK pour toi? Donc si on propose aux gens qui t'ont écouté de faire un retour en live dans le chat, l'idée c'est de donner une note entre 1 et 5 pour dire dans quelle mesure ils ont appris des choses, dans quelle mesure ils ont trouvé ça pertinent par rapport au sujet qu'on proposait. C'est OK pour toi?
Oui, bien sûr.
Et bah, du coup, le chat, je vous encourage à faire votre rôti. Donc, si vous êtes habitué à avoir des sessions des crafters, vous devez avoir l'habitude. Donc, on vous propose de mettre une note entre 1 et 5. Vous pouvez ajouter un commentaire, par exemple, sur ce que vous auriez aimé voir ou ce que vous... Voilà, et notamment justement pour avoir des idées pour la prochaine fois.
Pendant ce temps, sinon, je peux faire aussi la pub pour les prochains événements des crafters. Du coup, mardi 21, on aura un coding dojo du soir à 19h. Et le mercredi 29, on aurait un coding dojo du midi à 21h15. Voilà.
OK. Eh ben alors, donc merci beaucoup pour vos retours dans le chat. Alors attends, si tu me mets en grand, il faut que je remette la caméra alors. Bon, j'y arrive pas, désolé.
C'est pas grave, on va se quitter là-dessus,
comme
je
tu dis,
pense.
c'est pas grave. En tout cas, merci beaucoup
Merci.
donc à tout le monde, au chat. Merci beaucoup Allard pour ta présentation. On va tout faire pour réussir à te voir donc en 2022 physiquement. Ce serait super. Merci beaucoup encore à Axon pour déjà pour t'avoir mobilisé, pour les efforts qu'ils ont fait pour que tu sois là ce soir. Et puis, si vous avez d'autres retours voilà, plus tard, n'hésitez pas à les faire au crafter sur Meetup directement si vous avez des commentaires, et notamment justement s'il y a des choses que vous voulez voir pour la prochaine fois. Merci à tous, très bonne soirée, et puis à bientôt.
Et puis pour ceux qui veulent, on se retrouve sur Discord pour discuter. Par la suite, il y a un lien dans le chat. Au revoir.
Au revoir.